Welcome viewers. In the last video lecture, we cover modular arithmetics and also we cover this topic divisibility, and we saw that how to find quotient and remainders for different types of questions. Now, in today's lecture, we want to know about uh, different types of numbers, like that what is a prime number. Okay? Prime number, prime number. So a positive integer, a positive integer p. Okay, I mean it this number it should be positive. Okay, a positive integer p greater than 1. Okay, and this number should be greater than 1 is called a prime number. Okay, uh, if the only positive factors of p are 1 and p. Okay, means that the only divisor of this number p are 1 and p, then it is called a prime number. Okay, uh, and and a number and a number and a number which is not prime is called a composite number. Okay, so now we want to see that what are the examples of prime number. Okay, so prime number. Okay, see 2. It is a prime number because this 2 has only two factors. One is 1 and other one is 2. Okay, 3 has only two factors. One is 1 and other one is 3. 5, 7. Okay, 11. So in this way there are so many other prime numbers. Okay, now here you people note down one thing, that 2 is an even prime number, and it is only even number which is prime. Okay, we do not have any other even number which is a prime. So 2 is an even prime number. Okay, and it is the only even number which is prime. Okay, and 2 is the 2 is the smallest prime number. Okay, now next we want to see that if you are given one big number, okay, then how can you identify that this number it is a prime number or not. Okay, because in many competitive exam this question is basically asked. Okay, so show that question is this: show that 101 is a prime or not. Okay, so you see that the square root of, sorry, 101. Okay, uh, we are given this number. Okay, now you find two numbers, okay, which are perfect squares. Okay, so the first number is 100. Okay, and after 100 the second number, which is a perfect square, it is 121. Okay, so this 101, it lies between 100 and 121. Now take the square root. Okay, take the square root. Now when you take the square root, here you get square root 121. So it is 10 less than 101 less than 120. Square root of 121 is 11. Okay, now focus on this number. Okay, focus on this number. Okay, which is on this side, left hand side. Okay, so the number is 10. Okay, number is 10. Now what you do, find all prime numbers. Okay, less than less than or equal to 10. Okay, so find all prime numbers which are less than or equal to 10. Okay, so what are these numbers? Okay, see, 2 is a prime and it is less than 10. 3 is a prime and it is less than 10. 5, it is a prime and it is less than 10. And 7 is a prime and it is less than 10. Okay, now we want to check that any of these number divide this 101 or not. Okay, so see, clearly, clearly 2 does not divide 101. Okay, because 2 is an even number, so this cannot divide 101. Okay, now next you check it for 3. Does 3 divide 101? Okay, see, 3 divides any number if the sum of the number is divisible by 3. So what is the sum of number? 1 plus 0 plus 1, it is 3. Okay, so it means that 3 cannot divide 101. Okay, now 5, does 5 divide 101? See, 5 can divide only those numbers which end with either 0 or 5. Okay, so 101 neither ends with 0 nor with 5. So it means that 5 does not divide 101. Okay, then 7. Check 7 divides 101 or not. Okay, see, here we divide it 101. 7. Okay, 7 ones are 7. Now here 7 minus, sorry, 10 minus 7 is what? It is 3, 31. Okay, now 7 fours are 28. So you see that here as the remainder, it is not equal to 0. So we can say that 7 does not divide 101. Okay, now if any of these prime number, okay, if any of these prime number does not divide your given number, okay, then we say that the given number like 101 is a prime number. Okay, so this is the way to check that any number is a prime number or not. Now in order to make you people understand, we take one more example. Okay, I take one more example. So the question is, check 101, sorry, 151 is a prime number or not. Okay, so see here the number is 151. Okay, now find two numbers, okay, uh, which are perfect square. Okay, and this number 151 lies between them. So 144 and 169. Okay, these numbers, they are perfect square. Okay, for 144, it can be written as 12 square. Here it is 151, and this can be written as 13 square. Okay, now take the square root. So square root of 12 square less than square root of 151 less than square root of 13 square. Okay, 13 square. So what it is? It is 12 less than 151. Okay, less than 30. Okay, now you notice here that what number do you have on the left hand side? It is 12. Okay, so find all prime numbers less than or equal to this number. Okay, 12. So you see that here I have 2, I have 3, I have 5, I have 7, I have 11. Okay, so these are the numbers which are prime and which are less than 12. Okay, so now one by one I check that these numbers divide 151 or not. Okay, see clearly 2 does not divide 151. Okay, next we want to check that does 3 divide 151. See what is the sum of the digits of 151. It is 5 plus 1 6, 6 plus 1 is 7. So 3 doesn't divide 151. Now next one is 5. Okay, you see here that 5 cannot divide 151. Okay, 5 cannot divide 151. Now next one is 7. Okay, does 7 divide 551? See, 7 2s are 14. Okay, then it carries 1. 11. Okay, 7 1s are 7. So it does not divide. Okay, then does 11 divide 151? No, it doesn't divide 151. You can check it. Okay, so it means that neither of these number divide 151. So we can say that 151 is a is a is a prime number. Okay, now let me show you one example where we see that this number, it is not a prime number. For example, suppose you take 121. Okay, suppose you take this number 100. Okay, you take 125. 125. Check 125 is a prime number or not. Okay, so this we want to check. So it is very easy to check. See, this 125. Okay, it lies between 121 and 144. Now take the square root. Square root of 121 less than square root of 125 less than square root of 144. Now what is the square root of 121? It is 11 less than square root of 125. It remains as such, and square root of 144, it is 12. Okay, now notice what number do you have on this side? It is 11. Okay, so now prime numbers less than or equal to 11R. Okay, what are the prime numbers? See, 2, 3, 5, 7 and 11, because here equal to is also mentioned, so take this 11 also. Okay, now clearly 2 does not divide 125. Okay, 3, check, 3 divides 125. Now what is the sum of the digits? 1 plus 2 plus 5. So sum of the digit is 8, but 3 doesn't divide 8, so 3 does not divide it. Okay, 5, does 5 divide 125? Check, does 5 divide 125? See, clearly 5 divides 125. So you see that here we have found this number which divides your given number. Okay, so hence we can say that hence 125 is not a prime number. Okay, I hope you people have understood this thing. Now next we want to discuss about a fundamental theorem of arithmetics. Okay, fundamental theorem of arithmetic. So what is this? Okay, the statement is this, that positive integer every positive integer greater than 1, greater than 1, okay, can be uniquely uh, written as a prime or as a product of two or more primes. Okay, where the prime factors are, where the prime factors are written in order of non-decreasing size, non-decreasing size. Okay, so what is the meaning of this? That if you take any positive integer which is greater than 1, then it can be uniquely written as a prime. I mean, either that number is a prime number, and if it is not a prime, then it can be written as product of two or more primes. Okay, where the prime factors are written in the order of non-decreasing size. We write them in the increasing order. For example, suppose I take this number n equal to 5. Okay, so as 5 is a prime number, we have already learned this thing. Okay, so it means that I can write this 5 as a 5. Okay, so here you see that I have expressed this number which is greater than 1 as a prime. Okay, so this is first part. Okay, but suppose I take this number 12. Okay, so when I divide 12 by 2, what do I get? I get 6 here. Now again divide 12 by 2, so what do you get? 3. And here then it can be written as when you divide 3 by 3, what do you get here? 1. Okay, So this 12 can be written as 2 into 2 into 3. So 2 into 2 means 2 raised to the power 1, 2 raised to the power 2, sorry, and here it is 3 raised to the power 1. Okay, so you see that here I have expressed this 12 as a product of two primes. Okay, and these numbers they are written in the increasing order. First of all, I have written here 2 and then 3. Okay, now we take one more example. Suppose we take here number like uh, 65. Okay, suppose I take number as 65. Now divide 65 by 5. So what do you get here? 30. Okay, now 13 here, what do you get? 1. So this n can be written as 5 into 30. Okay, so you see that again I have expressed this number as a product of primes. Okay, so this is what is fundamental theorem of arithmetic. Okay, now next we want to talk about GCD, okay, and LCM. So first of all, I give the definition of GCD. Okay, GCD, GCD. It is also called greatest common divisor. Greatest common divisor. Okay. So what is greatest common divisor? Okay. So suppose that you take two number. Okay. Let A and B be integers. Okay. Note both 0. Okay. In both the numbers they should not be 0. The largest integer D such that D divides A and D divides B is called greatest common divisor of A and B. Okay. See here what we are doing, we are taking two numbers A and B and not both of them are 0. Okay. The largest integer D mean this number, it should be the largest number which is dividing both the numbers A and B. Okay, is called the greatest common divisor of A and B. For example, question is this: what is the greatest common divisor of 24 and 36? Okay, see, if you want to find the greatest common divisor of these two numbers, so what you do, you divide 24 by 2. Okay, here, so what do you get? Here it is 12, again divided by 2, what do you get here? 6, again divided by 2, what do you get here? 3, then divided by 3, so what do you get here? 1. Okay, so this 224 can be written as 2 into 2 into 2 into 3. Okay, now divide next 36. So when you divide it by 2, what do you get here? 18. Now again divided by 2, what do you get here? 9. Then 3 and 3. Okay. So 36 can be written as 2 into 2 into 3 into 3. Okay. Now circle the common numbers. Okay, so here 1 2 is common here. Okay, because it is in both the numbers. Okay, uh, next again 2 comes in this number and 2 comes in this number, circle it. Okay, then 2 comes here, but 2 next time it does not come in 36, so leave it. Next number is 3, 3 comes here. Okay, and here also we have 3. Okay, so now you notice there that how many common numbers do they have? They have 3 common numbers. So GCD of 24 and 36, it is simply the product of these common numbers. Okay, so 2 into 2 into 3, so what is it? It is 12. Okay, and you can check that this is the largest number which divides both these numbers, 24 and 36. Okay, uh, okay, whatever is your GCD, that always divides your even number. So you say, check that 12 divides 24 and 12 divides 36, and it is the largest number which is dividing both these numbers. Okay, now next question we see. Question is this, that what is greatest common divisor of 17 and 22. Okay, so solution. See, 17 can be expressed like this only, 17 into 1, and 22 it can be expressed like this only, 2 into 11. Okay, then further if you like you can write here 1 also. Okay, now you see that what is the number which is common in both these numbers? Okay, only 1 is the common. Okay, so here we can write that GCD of 17 and 22, what it is only 1. Okay, uh, okay, it is only 1. Now this gives rise to one definition. Okay, uh, that what are relatively prime numbers. Okay, now two numbers two numbers A and B are called relatively prime if their GCD it is equal to 1. Okay, for example, you can take number like 5 and 6. Okay, what is common in these two numbers? Only 1 is common. Okay, so 5 and 6 are relatively prime. Okay, but number like 2 and 4. Okay, what can be taken common from both these? It is 2. Okay, so it is not equal to 1. So 2 and 4 are not relatively prime numbers. Okay, now next we want to see one more thing. Okay, sometime this is also asked. For example, suppose that you have one number A. Okay, which is expressed like this: p1 raised to the power alpha 1, p2 raised to the power alpha 2, and so on, pn raised to the power alpha n. Okay, and suppose that you have another number B, which is expressed like this: uh, p1 raised to the power beta 1, okay, and p2 raised to the power beta 2, and so on, pn raised to the power beta n. Okay, now if you like to find the GCD of these two numbers, Then the formula for this is that P1, you write the first prime number, then take the minimum of alpha 1 and beta 1. Okay. Now take the minimum function of alpha 1 and beta 1. Okay. Similarly, P2, take the minimum of alpha 2 comma beta 2. Okay. And likewise Pn, take the minimum of alpha n comma beta n. Okay. So we learn this thing with the help of one example. In that case it will be quite clear to you. Okay. So for example, suppose I take one number as 6. Okay. So uh, 6 is what? 6 is question is this, that find GCD of 6 and 8. Okay. So 6, what it is? 6 can be written as 2 into 3. So here we have two primes. Okay, one is 2 and other one is 3. Okay, and 8. 8 can be written as only 2 cube. Okay, but we do not have any other prime here. So no issue. We can introduce it. So it is 3 raised to the power 0. Okay. Now what is the GCD of 6 and 8? You were told that first of all you write the first prime number, which is 2, in both these expressions, and then take the minimum power. Okay, minimum of here the power is 1. Okay, and here the power is 3. Okay, so minimum of 1 and 3. Next number is 3. Then take the minimum of their powers. Okay, so the first of all, for this number the power is 1, and for this number the power is 0. Okay, so it is what? It is 2 raised to the power. Now out of 1 and 3, which one is minimum? 1 is minimum. Okay, and for next case, which one is minimum? Only 0 is minimum. Okay, so 3 raised to the power 0, it is equal to 1. So what is the answer? Answer is 2. It means that the GCD of 6 and 8, it is just equal to 2. Okay, so what I feel you people have understood this thing. Okay, now we solve one more question. Okay, for example, find the GCD of 120 and 500. Okay, now you find the prime factorization of 120. In that case it is equal to 2 raised to the power 3 dot 3 into 5. Okay, similarly find the prime factorization of 500. It is 2 raised to the power 2. Okay, 5 raised to the power 3. Okay, only, but we do not have any 3 here, so no issue, we can introduce it. It is 3 raised to the power 0. Now GCD of 120 and 500. Okay, so what it is? It is 2 raised to the power minimum of 3 and 2, 3 raised to the power minimum of, what is the power here? Power here is 1 comma 0. Okay, then 5 raised to the power minimum of, what is the power here? Power here is 1 comma 3. Okay, so it is 2 raised to the power 2. Okay, next is 3 raised to the power 0. Next one is 5 raised to the power 1. Okay, so 2 raised to the power 2 is 4, 5 raised to the power 1 is 5. So 4 into 5 is what? It is 20. So 20 is the answer of this problem. Okay, now next we want to talk about LCM. Okay, what is LCM? LCM of two numbers. So LCM. LCM is also called least common multiplier. Okay, so we now see the definition of this. Okay, the least common multiplier of positive integers a and b is the smallest positive integer that is divisible by both a and b. Mean if you say that any number it is LCM, okay, then a and b should be dividing that number, and that number should be the least number, okay, and it is denoted by LCM of a and b, okay. So if you are given suppose two numbers, okay, suppose if you are given two numbers like uh, 8 and 50. The find question is if we have these two numbers 8 and 15, find their LCM. Mean what is that number, okay, which is divisible by both 8 and 15. So it is very easy. One way to solve the problem is like this, okay. First of all, you write your first number 8 and then you write the second number 15. Divide both the numbers by 2. So when you divide it, it gives me 4, and division of this it is not possible. So you write here 50. Now divide it by 2 again. So what do you get here? 2, and here you get 50. Now again divide. What do you get here? 1. What do you get here? 50. Okay. Now next divide it by 3. Okay. So here you get 1 and here you get 5. Now next again divided by 5. So what it is? 1 1. So when you get 1 in the end, so in that case uh, we stop here, okay. And LCM of these two numbers 8 and 15, it is just the product of these numbers, okay. It is just the product of all these numbers. So 2 into 2 into 2 into 3 into 5, okay. So what it is 8, 8 3s are 24, 24 into 5 is 120, okay. So you see that this is the number which is LCM, and 8 divides 120 and 15 also divides 120. So we solve one more question like find LCM of 3 and 10, okay. So write 3 on one side and 10. So divide these two numbers by 3. So here you get 1, here you get 10. Then you divide it by 2, here you get 1, here you get 5. Now divide it by 5, here you get 1. Okay. So what is the LCM? LCM of these numbers 3 and 10, it is just the product of these numbers. Okay. So 3 into 2 into 5. So it is 6 into 5. Here what it is? It is 10. So 10 is the answer. Okay. Now we quickly want to talk about one more result. Suppose that your A, it is expressed like this, uh, P1 raised to the power alpha 1, P2 raised to the power alpha 2, and so on, Pn raised to the power alpha n. Okay, and B, it is suppose expressed like this, P1 raised to the power beta 1, P2 raised to the power beta 2, and Pn raised to the power beta n. Okay, then LCM of A and B, it is given by P1 raised to the power maximum. In this case we take the maximum, but in case of GCD we take the minimum. Okay, so remember this: maximum of alpha 1 beta 1 into P2, maximum of alpha 2 comma beta 2, okay, and so on, Pn, maximum of alpha n comma beta n. So in this way, you can find the LCM. I just show you here one question. How can we solve the problem? So question is, what is LCM of numbers are given like this: 2 raised to the power 3, 3 raised to the power 5, 7 raised to the power 2, and 2 raised to the power 4, and 3 raised to the power 3. Okay, so you see that the first number, it is, suppose A, 2 raised to the power 3, 5 raised to the power, sorry, 3 raised to the power 5, and 7 raised to the power 2. And second number is B, which is 2 raised to the power 4, 3 raised to the power 3, and 7 is missing. So we can write it as 7 raised to the power 0. Okay. Now, LCM of A and B. So it is 2 raised to the power maximum of 3 and 4, 3 raised to the power maximum of 5 and 3. Okay. 7 raised to the power maximum of 2 and 0. Okay, so what it is, 2 raised to the power, out of these two number, which number is maximum? 4. Okay, next is 3 raised to the power, out of these two number, which number is maximum? 5. Next, 7 raised to the power, out of these two number, which number is maximum? 2. So this is the LCM of these two numbers. Okay, now we have one more result in our hands, and that result is let A and B be two numbers. Then product of numbers equal to LCM into GCD. Okay. See, if A and B are two numbers, then their product, it is equal to LCM into GCD. Okay. So you see that if you are given, suppose this thing, A into B, okay, and here you are given LCM of A and B, and here you are given GCD of A and B. Okay, suppose you know GCD, you know LCM, and you know A. Okay, then from this we can find the value of B. Okay, so this question is just solved like this only. Okay, so for example, question is, let A equal to 2 and B equal to 5. Okay, and LCM of 2 comma 5 is 10. Okay, so the problem is find GCD. So it is very easy. When you are given this information, you just substitute all these values in your formula. So here A into B, this is equal to LCM of AB and GCD of AB. Okay, so you see that A is 2 and B is 5. LCM here it is 10, and GCD here which we want to find. Okay, GCD is 2 comma GCD of 2 and 5 we want. So 10 and cancel. So what is the GCD? GCD of 2 and 5, it is 1. Okay. Now after this, one more topic we want to discuss, that what are pairwise relatively prime. Okay. So let A, B, and C are three integers. Okay, we may take more integer also, but suppose we take three integers. Let A, B, and C be three sorry, let these be three integers. Okay, then These numbers are called pairwise relatively prime if GCD of A comma B is 1, GCD of B comma C is 1, GCD of C comma A equal to 1. Okay, if the GCD of their ordered pair, okay, one by one, it is equal to 1, then we say that these numbers, they are relatively prime. For example, check 4, 5 and 6 are relatively prime or not. Okay, so if I take the GCD of 4 and 5, so you see that only one can be taken common. Okay, now if I take the GCD of 5 and 6, in that case only again one can be taken common. But if I take the GCD of 4 and 6, okay, so 4 is 2 into 2 and 6 is 2 into 3. So what is the common factor? It is 2. Okay, and it is not equal to 1. So GCD of 4 comma 6, it is not equal to 1. So it means that these numbers are not pairwise relatively prime prime numbers. Okay, so I just show you one example or one more example where we see that when the number become relatively prime. So check numbers 2, 5 and 7 are relatively prime or not. So it is very easy. Solution: take the GCD of 2 and 5. Okay. So only one can be taken common. Now take the GCD of 5 and 7. Only one can be taken common. Now the GCD of 2 and 7. Only one can be taken common. Okay. So GCD of all these pairs, this is equal to 1. So therefore we can say that these numbers are relatively prime numbers. Okay. So this is all in this video lecture. More about number theory will be discussed in the next class. Uh, you will be taught a Euclidean's algorithm and how to find the Bijout's coefficients. Okay, so this will be discussed in the next video lecture. Thank you very much, viewers, for watching this video. Stay connected with us for more updates.